Terrell Russell serves as Director of Data Management at RENCI, which is Renaissance Computing Institute, and serves as the Executive Director of the iRODS Consortium. He provides management and oversight of the iRODS Consortium and high-level architecture design. He's interested in distributed systems, metadata, security, and open source software that accelerates science. Terrell holds a PhD in information science from the University of North Carolina at Chapel Hill. Go ahead, Terrell.
Thank you, Dave. So I can talk to the four corners of the room. This is great. So yes, I'm Terrell. We're here in booth 4424, if you want to talk to us a little bit later. We're in the RENCI booth. So this year we've gotten iRODS 5 out the door, and it's been a long time coming, so I'm going to tell you a little bit about it. So first of all, this is not a company. This is a project, kind of a paper organization inside of the Renaissance Computing Institute at the University of North Carolina, Chapel Hill. Everything we do is open source. We give it away, and then we provide service and support and wisdom or something with that. We've got membership around the world. Most of our members are academic institutions or companies doing science, but we've also got some people doing hardware vendors and technology integrators who we train and then bring them up, and then they see us as a tool in their tool belt to meet the tenders and the RFPs that they're supplying. Abbreviated history here. This is a 30-year-old project now, which is kind of amazing. The first 20 years were funded science from NIH, NSF, DARPA, DOE, NASA, NOAA, lots of different communities. And about 12, 13 years ago, they said, that's enough, good luck, the things work. So we talked about it for a while and came up with the consortium model rather than spinning out a company or trying to monetize it in that way directly. And so we've had 12 years of proper software engineering wrapped around this project now, and so we've moved from kind of a philosophy and science project to more of a platform and almost a product. So this is good. It is open source. It's BSD 3. All of the things that we do are open, including our training, our documentation, and of course the code itself. It's mostly, well, the code, the server is all in C++. We have client libraries and things in other languages. This past year, we've picked up the pace because iRODS 5 is no longer have to be required to be compatible with iRODS 3, which is the project that we inherited a few years ago. For the lifetime of 4, we had a lot of compatibility code that we've now been able to remove in 5, so we can go a little bit faster. We've also spent a lot of time putting things in plugins over the last decade, and we are now starting to, now that we know things work and they're working as designed, we're going to pull them back into the core and kind of consolidate some of this work so that they can start to be available in administrative GUIs and things like that. Number of members has picked up a little bit recently. We keep finding out that people have been using iRODS for a few years. Because it's open source, of course, we don't know when people are using it, and then we find out later they've got petabytes under storage, under management, and that's great. And they think they found a bug, and then we write them back and fix their bug. We've also found some market clarity in the last few months. I think in the shifting winds of funding in the last year, we have identified that our academic and kind of supercomputing customers are a little bit different than the corporate world. The ones who we have found traction with want to know enough. They want to run it themselves. They want to go deep, whereas commercial companies see this as kind of a checkbox, right? This is not their way they make money. So data management for them is an operational expense, and they're happy to pay for that. And so we are actually seeking managed services partners. As a university, we're not really allowed to run code for other people, especially companies that could be angry later and come after the university. So we're happy to talk about that if you feel like this is something interesting and would like to partner. We're happy to investigate that with you. So iRODS itself is a policy-based, open-source virtual file system. So it's a C++ client-server architecture. It abstracts a variety of different storages and file systems We provide a metadata catalog, not just for system metadata, but for arbitrary user or scientist or tool-defined metadata, as well as, I think perhaps most importantly, a rule engine. So this is a programmatic environment where every operation in the system can be triggered or can be a trigger for your code to go out and do something interesting. Either reformulate some data, chop it up, move it around, send API requests, do some stats, whatever needs to happen. And that can happen live, if that's important for your policy, or it can happen in a delay environment where it's, for statistics and kind of roll-ups. iRODS is its own protocol. It has its own RPC API, and it's all BSD3 licensed. And so talk about that a little bit more in the next few slides. It does run on a number of servers and machines if you want it to. It can also just run on a laptop. It can run here, there, in the sky, and all of those at the same time. So depending on your networking and firewall requirements, those can be satisfied. And catchphrase this year is data-centric and metadata-driven. So we are about the data, but it's a matter of policy. If you describe things well, you can have humans and software take action on the data based on the metadata. And so with this type of philosophy and approach, you can insulate your people, your data, your policy from the changing infrastructure over time. And so we have seen people run through the fire a couple times of a migration and an end of life and end of support. And after they do that a couple times, they realize, oh, there must be a better way. And so we try to elevate that conversation and not have you run through the fire anymore. So please come talk to us. We'll save you some time and money. iRODS is used mostly in research, commercial, and government organizations. Largest user base in the last few years has actually been in Europe for a variety of reasons. They've got stricter data protection laws. The policies are stronger. The teeth are sharper. There's also been an uptick in data sovereignty concerns. We've seen a lot of European countries and commercial entities declare that they are not allowed to put data in an American cloud. And so that provides an opportunity and a challenge depending on whether you're an American cloud. Also, their funding models generally require a deeper federation and kind of locking of arms and working together in a way that a lot of the entities in the U.S. don't require with their funding. And we really are about the 100-year data management needs. So if you're having a conversation longer than the next quarter or the next couple of years, I think you should probably talk with us. It does keep your infrastructure flexible. Here's a bunch of letters that tells you where stuff is running around the world. We have seen an uptick in supercomputing centers actually deciding to run iRODS as they are realizing there's more value in some of their older data. Having a way that you keep that around and make it available maybe to the AI robots that want to come and give you some insight. This is interesting and good. So medical research centers, also more interest in the last few years. We have not yet cracked kind of financial institutions, banking, things like that. But medical side, genomics, when they had their data deluge 10, 12, 15 years ago with the sequencers, they found us. Libraries and archives found us before that. iRODS was originally for plasma physics. It was to solve the problem of the simulation data didn't fit on a single disk. And so it started out as a grid storage solution and now has policy behind it. So iRODS 5, like I said a little bit before, we've been unshackled by our promise to the community for the last 12 years. So we were able to remove quite a bit of compatibility code where we made promises to iRODS 3. iRODS can federate with itself, and so version mismatch is a feature depending on how long it takes you to upgrade and who your partners are. You're not necessarily in charge of your federated compatriots' upgrade schedule, and so these things have to be staggered. So we've done a lot of work around the process model and the service manager inside the system. Our secondary tagline, our unofficial tagline is normal and boring. We're trying to make this system something that system administrators are not surprised by, things they've seen before, best practices in regards to handling signals and being responsive to configuration reloads and all that kind of stuff. We've also unified our configuration file, which means that it's much easier to deploy this in an automated fashion, kind of hands-free, We've seen a lot of uptake in some of our customers with Kubernetes-driven deployments. And so the more they can automate, the more they can keep things, infrastructure as code. All these types of things are good. TLS stack has finally been updated. Again, since we had to be federated with a thing from a decade ago, this liberated us, and so we're up to OpenSSL 3. We've added access time tracking to iRODS. iRODS has always been able to see creation times and modification times, but access times are a little bit trickier because they can bog down your system if you're tracking them live. So we've implemented something basically identical to the Linux kernel. There's a relative A time. So if it hasn't been touched in the last little bit, we'll ignore it. If it's recent, we'll put it in a queue. And these things get batched up by a process in the background. So they're not real time because that would be super slow. But it is now available, and what that means is that when we start to focus on metrics and being able to give information for tiering, these things are very clear and demonstrable, right? These are very clear in the database. We've also got the concept of running rules, now or later, and the later situation was always a little bit trickier because we could have multiple machines in the system. There had to be a single source of truth. These rules could step on each other potentially if you wrote things that were trying to do some of the same work at the same time. So we now lock those and make sure that they are very cleanly separated. We only saw that on some of the biggest, most traffic-heavy situations. But when it did, it's tough to track down because you had a race condition. It was hard to see. The other thing that we've done, which was a major can't use that word, the general query that we provide. So iRODS is built on top of a relational database. That's where all the truth lives. And we provide not direct SQL because our parser is the thing that the query language is what provides the permission model. So we don't let the users issue any join information in their SQL because that would allow them to get around the permission model. So GenQuery parser that we had for a long time had a few limitations because it was conceived of and implemented 25 years ago. So GenQuery 2 now has a lot more. It's a full-featured, proper parser and allows us to be in control of the vertical and the horizontal. So we've got full control over that. If there's something that you think that we're missing, at this point we can add it probably within a day or two, which is great. In addition to the core server, lots of client libraries to meet people where they are. We've got Java, Python, all the things. Some of these are provided by us. Some of them are actually maintained by some of our community members, some of our organizations that are depending on iRODS to get their stuff done. In addition to that, there's lots of client applications that have been built either for generic purposes or by people to solve their custom needs. And that includes things that present iRODS as different protocols, but also some administrative tools. We've got a new MCP server that was recently launched by Arizona. And that means that some of this, all this work and policy that's available in iRODS is visible now to your AI agents, potentially. This is a little bit more about the protocol plumbing effort. iRODS itself is a protocol down here that not so many people know or have implemented things against. It is not HTTP. It is not the things that maybe you've already known about. So the yellow are client libraries that we have. And then on top of those are different protocol implementations where we can now present an iRODS zone with all of its policy and its metadata and everything can now present and be accessed through WebDAV, NFS, Fuse, SFTP. You can present as S3. So if you already have tooling and pipelines and scientists who are used to putting things in S3 buckets, iRODS can now be S3 buckets. And you don't have to build different machinery at the edge or in the lab or wherever you're doing it. In addition to that, we have an HTTP API now, so we've got web developers who can build custom clients for you very quickly in a way that was a little bit tricky before. And so the HTTP API actually covers the full power of what iRODS can do. NFS, of course, can't see the query engine. It can't see rules. It can't think like things like that. So depending on some of the limitations of the protocol itself, this might be only good for data movement or data staging or permission models, but we meet people where they are as much as we can. One of the things that we're probably going to be pulling back into the server is the storage tiering plugin that we've had. This is a metadata-driven, completely storage agnostic, open source free way to build an HSM, a hierarchical storage manager system, across your arbitrary storage that you may already have or would like to buy in the future, right? So if you have something fast, something medium, and something else, right, and they could be here, they could be there, they could be up in the sky, with a little bit of metadata in the right place and some annotations around querying and what you think is important, when is the time to move data from tier 1 to tier 2, whatever. This just works, and it's saving people a lot of money. So this is a slide, it's my favorite slide, from the Netherlands Cancer Institute from last year's user group meeting that we had. They priced out, they had everything on a super fast file system, and it was getting out of hand. It was getting too expensive. So they priced out that was costing them 200 euro per terabyte per year for their fast storage connected to their HPC systems. And they had some cloud archive that they were interested in, and they implemented this at 30 euro per terabyte per year. And when they did the analysis, they found that 80% of their bytes, 80% of their storage had not been touched in 6 months. And this is a classic tale, we know this. But it turns out it was 92% of their files, 80% of their bytes, 92% of their files. When they implemented this solution and let it run and tier everything out that was correct, they saved over $423,000 annually hands-free. And so I'm trying to get all of our members to make this slide as fast as possible, because I think it does a good job of pointing out how this works. iRODS itself is extremely flexible in its deployment patterns. We do our own demos, we do our own trainings, we do our own testing and things, mostly over there on the left, where there's one iRODS server, one catalog, and then a number of storage systems that are interesting to the test or whatever that we're doing. The limitations of that, of course, that there's not really much redundancy. You can overwhelm it with concurrent users. Most iRODS systems, once they're deployed, they're big enough that they require multiple servers to be in multiple places, and that's kind of the middle here, the classic thing, where there's still one catalog that holds the source of truth. The iRODS servers talk amongst themselves when they need to, and that's how they get locality of reference. That's how they get through the firewalls. That's how they can have both local as well as remote storage. That requires a lot of connectivity. That requires the people running the system to understand host names and networking, and it's just there's some hill climbing to do that well. And potentially, if it's implemented poorly, it can actually hurt performance pretty dramatically, because you might have things that are routing around depending on what you've configured. We've seen sophisticated users recently move more to the right, where they have all of their servers have access to the catalog, and all of the servers have access to all of the storage. This is more of a kind of a Kubernetes style, oh, I need more. You kind of just turn it up and you get more servers, and you turn it back down when you don't. It means that the servers don't have to communicate directly amongst themselves. They don't need hostname information for each other, which means the configuration is easier and faster, and fewer bugs in that regard. Limitations there are that obviously you have to have your database credentials in more places, but maybe if it's automated, that's not a problem. If your security is good, that's not a problem. The other thing is that doesn't allow you to have any local storage anymore. So if the servers can't talk to each other directly, they can't reroute and go get the data from wherever it was connected. So you have to have all of your storage, parallel file system or S3 buckets or whatever it is, kind of available to everything. But it turns out to be much faster in that way. The things that we're spending time on right now, again, once you start spanning multiple systems and multiple departments and multiple labs and multiple organizations, the metadata starts to matter. The ontologies and the data dictionaries that you're using matter more and more. And if they're not consistent, if they're not good, your discovery goes way down. You can't find things when you want to. Templates are how you can enforce the quality of the metadata describing the data and the data sets and the protocols and the pipelines and all the kind of stuff that you've got. If you've got stuff coming off of microscopes, you should gather as much information from the scope at the point of access, the point of description, the point of imaging as you can. And with automated tools, you can now validate those metadata templates. You define those in JSON schema, they live somewhere, you attach them to data sets, and iRODS can enforce or just inform you when things are not up to snuff. But if you're building pipelines, you can then build gates so that things can't go from stage 2 to stage 3, stage 4 to stage 5, because the metadata is not good enough. You have to send the scientists back, you have to send whoever back, go make it good, and then this data is eligible to move forward. This is a matter of organizational policy and rigor, and the grown-ups are doing it, and if you're not, then it could be a mess, right? We've also been spending a lot of time on metrics and visibility. I talked about A-time earlier. We've got some tooling now where a lot of this information's in the catalog. We can see it. It's just a matter of SQL, but making it available for executives and people who actually are paying for this kind of stuff is good. We've been thinking about AI agents. Like I said earlier, we've got an MCP server now that came from the community. There's another talk that we're giving called iRODS and AI, Preventing Garbage In. I mean, the pitch is, if you don't have good data, you're not going to get good analytics, right? You have to have an understanding of what is in the system before you feed it to the robots and they start chewing on it and spitting out answers. And that's going to be true in a loop, right? I hope you've not yet plugged your agents into your agents, but people are going to start doing that. And if you don't know what happened, especially in kind of a stochastic environment where these things are non-deterministic, you need to understand how your outputs are going to relate to your next inputs. And so all that to say that if you are in a compliance environment where you've got regulatory requirements over your head, if you've got health things, if there's safety, if you're in a hospital, again, you can enforce these rules, you can enforce these policies in a way that can take the load off some of the humans that have always had to spend time doing that and let them get back to something interesting. And again, of course, the active collaboration right now, we're seeking partners who can run out front and take some of that risk and the cash for running managed services. We think that we provide a lot of tooling over and above a lot of the things that are out there, even on the floor out there today, and the fact that we're open source. So I think that there's some disruption that can happen, but we as a university aren't really allowed to go do that. We would have to spin something out ourselves or have 3 jobs and like this, looking for partners for that. And I think that's it. Thank you. Are there any questions?
If there's any questions, just hold your hand up and we'll get a mic to you.
I would like to hear what's hard. What can you not do right now?
Thank you. Thank you. You had a slide about federation, but you didn't talk about it much. Can you just tell us a little bit about how you federate between different...
Yeah, I don't have a slide on that right now. So federation is really about having 2 zones, 2 namespaces. Maybe it's your organization and another organization, or maybe it's different buckets of money in one organization, depending on who's paying for things. And so at the protocol level, iRODS can share a few keys, and then they can see each other. So iRODS has a namespace. We call it a zone. And everything in iRODS is a logical path, separated from the physical paths of the storage underneath. So the logical paths always start with / the zone name. If you are federated with another zone, then they become sibling zones in the namespace, and they can traverse each other. So a user in one zone authenticates at home, and then gets a magic token and can go visit the other zone through the namespace. And depending on what permissions they've been given in that zone by those administrators, they're allowed to see things, access things, change things. But we are a full POSIX compliant, ecosystem, regardless of the type of storage that's underneath.
So can you have like federated groups across that, or is it just a per user permission on another federation?
So the other group, the other zone is in charge of what they do. They could put my visiting user in a group, but my group definition has nothing to do with their zone because that's a different administrative unit. Does that answer the question?
Yep.
Okay.
Good. Thanks.
Yeah, and since we are, all of our authentication is pluggable as well, so we can depend on LDAP, Active Directory, Kerberos, all that stuff is pluggable in addition to the kind of native stuff that we handle. So if you've got if there's a sophisticated environment where there's already a lot of grouper happening or Active Directory, it just fits in and we'll tie in.